Hello, chemistry students. In this video, I want to walk you through how to identify a single replacement reaction and predict the products of that. This go over the notes that we went over in class, and you can download the notes and follow along with the video and fill along with our examples. All right, the first thing we're going to take a look at is what is a single replacement reaction. And just like most things in chemistry, the name is very explicit. Single means one thing will replace something else in a chemical reaction. In this case, the element that's outside, that's not joined in a compound, we're going to look at that as symbol A, will replace another element in the compound to produce a new compound and a new element. So by definition, one single element replaces another in a compound to create a new compound and new element. Okay, well, how do we know if A can take the place of B to make that new compound? We're going to look at something called an activity series, and it is a list of different elements in order, as you can see here, of their reactivity, with the more reactive elements at the top, the less reactive elements at the bottom. This one is separated by metals at the top, so we would compare two positive ions, and to nonmetals on the bottom. Sometimes the element you're comparing is a nonmetal, so you'll look for the negative in the compound. All right, so the other thing that we're going to take a look at is what happens. Well, if I say in this reaction here that we have potassium and it may react with hydrogen bromide, if we look at the activity series, we're going to try to decide, can potassium take hydrogen's place? So right now, hydrogen and bromine are combined together in a compound, and unless potassium is more reactive than hydrogen, this will just stay the same. It won't change. There won't be a reaction. But if potassium is more reactive than hydrogen, then we would get a new compound. And I'm comparing these two because potassium is a metal, it's positive, and in this compound, hydrogen acts like a metal, it's also positive. So I can compare those two. So I'm going to look at my activity series. Potassium looks like it's pretty high on the list, and hydrogen's kind of down in the middle. So this would work because the potassium can take the place of hydrogen to make a new compound, and you see that over here. Potassium combines with the bromine, and then hydrogen is kicked out. It's left alone on the product side. Well, you know, hydrogen by itself can never be truly alone because it's diatomic, so it becomes H2. Then working back with coefficients, we balance by adding a 2, 2, and 2 to make sure there's the same number of potassium, hydrogen, bromine on both sides. Well, what happens if that element that's trying to replace one in the compound is less reactive? Well, let's take a look at an example like that. Aluminum and calcium. When we look at our activity series, aluminum is below calcium. Therefore, it cannot take the place of calcium and we get no reaction. We just abbreviate that as NR in our problems. And that happens because calcium and chlorine are already connected together, and it's going to take something far more reactive to separate those. And aluminum just isn't quite reactive enough. All right, so then they stay in the compound that they already have. In the class today, I had a demonstration with 3 different test tubes, and each one of them had some hydrochloric acid, HCl, and then I tried to react different metals with that hydrochloric acid. And what we saw was pretty interesting. The zinc, it turns out, it did react and it made bubbles. So we saw some bubbles, and a gas was being produced. When I combined copper with hydrochloric acid, we didn't see anything at all. No bubbles, no gas, and no heat. Oh yeah, we also got a fair amount of heat from this reaction as well. So how can I justify that happening with the activity series? Well, let's say we take a look at our element that's trying to replace. And if I look at the zinc, zinc is trying to take the place of hydrogen in this new compound to combine with chlorine. If I look at where they're at on the activity series, hydrogen's in the middle, and zinc is on top, so it's more reactive, so it can easily take its place. So we have zinc then combining with chlorine. I have to be a little careful because when I write the formulas, I have to keep following the charge rules. And zinc, as we know, is always a +2 charge. So that's going to make, because chlorine is a -1, it's going to make it formula have a subscript of 2 after chlorine, so ZnCl2, plus my hydrogen gas. H2 is what's left behind. Can't be alone, diatomic. Now I can balance the whole equation. I see 2 chlorines, so I'll put a 2 in front of that, and that takes care of the 2 chlorines and the 2 hydrogens. So now I have a balanced equation that's predicted the products of the single replacement reaction. All right, and it works because I saw it work. It made a bubble and produced heat. Copper, on the other hand, if I look at where that's at on the activity series, the copper is way down here. Oh yeah, right there. So it's far less reactive than hydrogen, therefore nothing will happen. Nr, no reaction. We're going to compare lastly magnesium. All right, so I'm going to take a look at magnesium. Can that take the place of hydrogen? Yep, you guessed it, sure can. Magnesium's up here. So it can easily take the place of hydrogen in this compound to make a new compound, MgCl. And remember, magnesium again is +2, chlorine is -1, so it becomes MgCl2 plus my hydrogen gas. All right, now balancing this, it's going to be really similar. I have 2 chlorines and 2 hydrogens, so I'll put a 2 in front of this and 1 magnesium. Remember, when you're predicting that you want to make sure you write the correct formula using the charges, like we did here, then go back and balance the whole equation using the coefficients, like we did here. Those 2 things we have to keep in mind all the time. All right, a couple other examples, and then I'm going to have you guys try this. So if you could please take a look at these 2 examples where I have magnesium and aluminum chloride. Magnesium is more reactive than aluminum. Check on the chart, but it's higher on the list. And that means that it will kick aluminum out of this compound and take its place. So magnesium combines with chlorine, and that leaves aluminum by itself. Wait, Mr. Standerson, can aluminum be by itself? Sure can. It's not a diatomic, so I don't need to put 2 as a subscript. Now I do need to go back and make sure I have the correct coefficient after I write the formulas correctly. So I'll do that by balancing the magnesium, 3 magnesium on this side, 3 on the other side, the aluminum, 2 aluminums, 2 aluminums, and the chlorines. 2 times 3 gives me 6, 3 times 2 gives me 6. So I'm going to make sure that's balanced in the end. All right, lastly, what if the element that's trying to replace is a nonmetal? Like here we have bromine. Well, bromine is a nonmetal, it's negative charge. It cannot replace the positive because that would put 2 negatives together in the compound. It's looking to replace the other negative, in this case iodine. Sure enough, it is higher on the nonmetal activity series. So when you look at that, look here for the nonmetal activity series. We have bromine and iodine, and bromine is going to win. It's on top. So now I can replace that in the compound. So I'm sorry, I can move my bromine, but the potassium stays first. KBr, +1, -1, plus my iodine is diatomic, so I2. This already is balanced, so I don't need any coefficients, and I'm done. Okay. Please review these notes. Take a look at this. I'm going to leave the answers for the last 2 so you can check over your work, double check that that makes sense and you've done it correctly. And then I'm going to ask you to please look at a homework sheet for today. So I'm going to pull that up real quick. For your homework sheet, I will post this key, but I want you to try it on your own. Keep in mind that you first want to look at your reactants. And if the first element is a metal, use the top part of the activity series chart to replace the other positive in the compound. If the first thing is a nonmetal, a negative, look to replace the nonmetal or the negative in the compound and use this bottom part of the chart. All right, so for the first one, we are going to look at copper and iron. They're both metals. Copper is less reactive, so there's no reaction. But zinc is more reactive than iron, so zinc will take iron's place, and it becomes zinc nitrate. Zinc has a +2 charge, nitrate has a -1, so if this is +2 and nitrate is -1, I need 2 nitrates to make that balance out. So I put it in parentheses and the 2 subscript, and now I look through the coefficients and it is all balanced, so everything is good. All right. If you need to balance the full equation, like in number 4, notice I am going to take the sodium and replace the iron because that's more reactive. I get sodium nitrate, +1, -1, no subscripts needed or parentheses, and the iron is by itself. This isn't balanced, however, so I need to go back and make sure there's 2 nitrates on both sides. So I'm going to see the 2 here that multiplies by nitrate. The 2 coefficient will multiply by this thing that has nitrate in it. And that also means 2 sodiums, so I need a 2 in front of the sodium there. This happens because sodium is more reactive. Don't forget to go back and balance your equations. All right, that kind of wraps things up. I'll post this key on Schoology for you to take a look at it. Please reach out if you have any questions.